everybody. In this video, we're going to talk about how to calculate z-scores as well as what they mean. So take 3 deep breaths and let's make this math easy. All right, so the formula for calculating a z-score is super simple. You basically take the value that you're looking at, subtract the mean, and divide by the standard deviation. And what this calculation will give you is a score that tells you how many standard deviations your value that you're looking at is away from the mean. So for example, if we go back to this situation where we're working with elephants, and we know that the mean weight of an African elephant is 12,000 pounds with a standard deviation of 800 pounds. And so in a previous video, we learned about how the mean of the data, 12,000, is where the bell curve is going to be centered around. And then we also learned about how the empirical rule tells us that within one standard deviation, you would have 68% of your data. And so like if you add a standard deviation to 12,000, that would give you 12,800. And if you subtract 800, that would give you 11,200. And then you could also do the same thing if you went 2 standard deviations away, and that would be 95% of your data. And then if you go 3 standard deviations away, that's 99.7% of your data. So that's a little bit of a review of the empirical rule. And what the z-score allows us to do is to figure out how many standard deviations away an individual in the population is from the mean. So let's say, for example, that you have an elephant that weighs 10,000 pounds. Well, we know that this elephant is below average because our average is 12,000 pounds. But the question is just how far away is it? And the way we calculate it is we take our value, which is 10,000 pounds. We subtract the mean, which gives us 12,000, and then we divide by the standard deviation. So 10,000 minus 12,000 is negative 2,000, and if we do negative 2,000 divided by 800, we get negative 2.5. So this number is the z-score for this elephant. And basically what it's saying is that this elephant is 2.5 standard deviations below the mean. So essentially, this elephant is kind of about here in the chart. And we can see that this is reasonable because if we calculate out what 2 standard deviations away is, we take 11,200 and subtract 800, which would give us 10,400. And then if you subtract another standard deviation, that would give you 9,600. And we can see that this elephant is in between these 2 standard deviations. If you go 2 standard deviations below, you get 10,400. If you go 3 and below, you have 9,600. And this particular elephant that we're looking at is about halfway between those. And so that's what the z-score means. So on your assignment, you guys are going to be using z-score tables to calculate percentiles. So a percentile basically describes what percentage of the population is less than that individual. So you may have heard the term percentile when parents have a new baby. Like they might say something like, oh, like my child was in the 85th percentile in weight or something like that. And basically what that means is that their baby weighs more than 85% of the population or 85% of babies that are born. And so that's what the term percentile means, and you can use z-scores and z-score tables to help you calculate the percentiles. So for example, if we wanted to figure out what percentile the elephant that we looked at on the last slide is at, then we could say, okay, well the z-score, or the number of standard deviations that this elephant is away from average, is negative 2.5. And so I'm going to go to my z-score column and go down to negative 2.5. And then depending on what the next decimal is, I'm going to look at the columns. So in this case, since it was negative 2.50, I'm just going to go to the 0 column. And this is going to be my percentile. Now, if it had been negative 2.56, then I would have gone over to this one, because basically the column represents the second decimal place and the row represents the first decimal place. So for our elephant that we looked at, this is our percentile number. And it basically describes what percentage of the data is less than that elephant. And so if you change that into a percent, because this is in decimal form, what that tells us is that 0.62% of elephants are lighter or less heavy than the elephant that we were looking at. And so this elephant that we were looking at is pretty much the runt of the group of elephants, because there's only 0.62% of elephants that are lighter than it. And so that's how you can use z-scores and z-score tables to figure out what percentile an individual is in. So why don't you try this one on your own? Pause this video, calculate the z-score for this giraffe that we're given, and then restart this video to see how I would solve it. Okay, so the way that we're going to calculate the z-score is we're going to say that our z-score equals the height of the giraffe we are looking at, which is 20. Then we're going to subtract the average height of a giraffe, which is 19. And then we're going to divide by the standard deviation. So we get 0.8 as our standard deviation. And when we do 1 divided by 0.8, that tells us that this giraffe that we're working with is 1.25 standard deviations away from the mean. And this makes sense because if our mean is 19 and our standard deviation is 0.8, well, going 1 standard deviation above the mean is going to be 19.8. And if we go another standard deviation above the mean, that would be 20.6. And so our giraffe that's 20 feet tall, it makes sense that it's going to be about 1.25 standard deviations away from the mean. We could go back to our z-score table and see what percentile this giraffe is in. So if our z-score was 1.25, then I would go down to 1.2 for my first decimal, and then I would go to 0.5 as my second decimal. And when I look at my table, it looks like the percentile for this giraffe would be 89.4%. So basically what that means is that this giraffe is in the 89th percentile, and that means that this giraffe is taller than 89% of the giraffes. So to recap this, the way that you calculate the z-score is you take the value for the individual that you're looking at, subtract the mean, and divide by the standard deviation. And then you can use that z-score to interpret how many standard deviations away from the mean your individual is at. And you can also use z-score tables to find the percentiles. So I hope that you guys have a great day, and I hope this video was helpful.